Our recruits now have a pretty good idea as to when they should use a multiplication operation. Now they need to learn a few terms specific to this op. Feel free to join me as I run a little operation of my own.
Time to regroup. I told you when we returned, we would focus on a few terms that would help us communicate and understand how to carry out our multiplication operation. And while we're at it, we'll learn to write the secret code as well. In our example, with 7 packages of 10 cookies each, we have 2 numbers, one of which tells us how many packages there are. That would be
7.
And the other one tells us how many cookies are in each package, which is
10.
And a multiplication operation, these 2 numbers are both referred to as factors. But even though they share the same name, they each have a different role in the operation.
If they're both called factors, how do you know which one you're talking about?
I know. It's like having 2 recruits with the same name. Every time you call on one of them, they both answer, right? We're going to give these factors a second name, one that will help us tell them apart by the job they do. And we will use the origin of the word factor to do so. Factor comes from the French word facteur, which means agent. And facteur comes from the Latin word facere, which means 2 things. It can mean maker, but it can also mean doer. These 2 words work perfectly for us, because in a multiplication operation, one of the factors makes the other repeatedly add itself the number of times specified by that factor. In our example of packages of cookies, which factor would be the maker?
I think it would be 7. Since there are 7 packages of cookies, with 10 cookies in each package, seems like you would make 10 add his amount 7 times.
Very clever. And I do so love to be the maker, I must admit. Now, which factor would be the doer?
I'm pretty sure it would be 10, since 10 is the factor that has to do something. This factor has to keep adding his amount until he has added it 7 times.
Absolutely and positively correct. So henceforth we shall refer to these factors by the job they do. One will be the maker, and the other the doer. As I said earlier, we will also learn how to write the secret code for this operation, just as we did with addition and subtraction. There are actually 2 ways we can write this code. For this example, we will write the code horizontally, across the page. When writing the code this way, we start with the maker, which in this example would be
7.
So, on the left side of your whiteboards, write the number 7. Now, after the maker, we write the secret sign for multiplication, which looks like the letter X. Go ahead and write an X after the 7. Now we write the doer, which in this case would be
10.
10 it is. Go ahead and write a 10 after the X. Now, anyone that is working on this operation with us can read our code and know just what to do. They know that they must multiply 10 by 7, which is the same as adding 10 7 times. That, of course, is the long way around. Any agent reading this code would simply know that 7 times 10 is 70. Now, once we've identified agent X as 70, we add this sign, the one mathematicians refer to as the equal sign, and then the number 70, which they call the product. I suppose they call it that, because that is what 7 groups of 10 produces. So, to your code, add the equal sign and the product. Now, show me what you've done, recruits. Excellent. Now let's see if we can identify the maker and the doer in the second example, where we needed to find the total number of chairs in a room with 9 tables, with 6 chairs at each table. Now, what would the maker be in this situation?
Let's see. There are 9 tables, and 6 chairs at each table. So it seems like 9 would be the maker, and he would make 6 add itself 9 times.
So then 6 would be the doer, since he would be doing the work of adding his amount 9 times.
You will make fine agents someday, but all agents must know how to read and write the secret code. This time, I want you to write the code vertically, down the page. But rather than starting with the maker, when writing the code vertically, we begin with the doer. So at the top of your whiteboards, write a 6. And directly beneath the doer, you write the maker. And in this case, the maker is
9.
Now to the left of the maker, you write our secret sign for multiplication, which is
The X.
Yes, indeed. Beneath this symbol and the maker, you draw a line. And once you have determined H and X's identity, you write it beneath this line. And recruits, remember to write your code neatly, as it makes it easier for other agents to assist in the operation if your code is more legible. I hate it when I'm slowed down by some operative's sloppiness, and I'm forced to not only do the necessary calculations, but decipher his code as well. If we were to go the long way around on this operation, 9 would make 6 add his number 9 times. 6 plus 6 is 12, plus 6 is 18, plus 6 is 24, plus 6 is 30, plus 6 is 36, plus 6 is 42, plus 6 is 48, plus 6 is 54. Phew, what a lot of work! Can you see why it is essential that you simply learn these facts? So, beneath the line you drew, write 54. What did I say mathematicians like to call this?
The product.
Absolutely and positively correct, because that is what adding 6 9 times produces. Now, let me see your code, recruits. Good work. Now, I want to see how well you can write the code on your own. I want all of you even number recruits to write the code horizontally, and all of you odd number recruits, you write it vertically. Let me see. For this example, we needed to find the total number of eggs in 3 full cartons. So, you need to determine which number is the maker, which is the doer, and at this point, do not worry about doing any calculations. Simply write an uppercase X, short for Agent X, where you would normally write the product. I'll give you a minute, but be quick about it. Alright, recruits, show me your code. Excellent, and neat as well. Since we don't yet know our multiplication facts, we have to take the long way around to calculate the total. Since there are 3 cartons, 3 is the maker, and he makes 12, who is doing all the work, add his number 3 times. 12 plus 12, which is
24.
And 12 more, and that makes a total of
36.
Splendid work. We have one more thing to learn before we delve into our basic facts, but we'll save that for the next session. Excuse me a moment. Yes? I see. I'll be right there. Well, my dears, it has truly been a pleasure. But duty calls.
Where'd he go? He just disappeared.
Probably off saving the world from some numeric disaster.
And I imagine it's so classified that we never will learn why he was called away so suddenly. Join us next time when Agent 007 shares with us how to have a gut sense about how an operation is going. This one will really help you further your career as a math operative. See you then.